Multi-threading in .NET. Okay, perfect. So let's understand what is multi-threading first, and then we'll actually go to actually implementation of multi-threading in .NET. What are the different things we have in multi-threading now, right? Now, before actually going into multi-threading, let us understand. We normally have few terms in which we normally use in our real-time working model, right? Which are single tasking, right? And you have multi-tasking and multi-processing. Right? So these are the different, tasking models we have in real time. So are they same? Are they different? Or do we normally have tasking and threading are same, multi-processing and are same? So do you guys have any idea on this? Right, not at all. So in single tasking, right, and multitasking and multi-processing, do many things at a time. Okay, correct. So is it same as multi-processing? Akila said multitasking is doing multiple things, multiple tasks at the same time, which is correct. Okay, not a problem. We'll see in detail. We'll see what exactly is tasking, single tasking, multiple tasking, and processing, and then until else we understand this, we only understand actual threading. Yes, as a concept wise, we can understand, but actually where exactly we need a threading is something which you will understand until unless you have an idea on this, right? So let's see what exactly is the tasking, and then multitasking, and then processing. So let me just open up the presentation. So let's see what exactly is single tasking. With the name itself, it conveys that single tasking is the one which will allow you to do one task at a time. Right? You won't be able to do parallel tasks at a time. Like let's take a simple graph. Of let's say you're doing some task and how much time it is taking. So let's understand how much of the process we are using to in a single tasking graph hardware, right? So let's say a programmer, a student actually codes for 15 minutes. He writes a simple code for 15 minutes time, which means whenever he is writing a program, right? He is just using the process to write a program. And after 15 minutes, let's say he executes it. Right? Which means normally a process will be obviously it will be fast enough to actually process at least a program which is 15 minutes, right? So let's say our processor took like 1 millisecond or let's say some 10 milliseconds to run this program. So that is after the 15 minutes of programming is done. Now once it is done, let's say student again started writing a program, and this time he wrote around let's say 20 minutes program. Now after that, let's say he started executing this program, and this time let's say it took around 1 second. Let's say that it only will take 1 second for the program you're writing in 15 minutes. Let's say the student who just started writing the program, and after that he again started writing the program, right? Where again let's say he wrote the program for 20 minutes, and again he executed it, and it took 1 second. So here you can see that across the times, right? He actually spent about an hour, right, to write a program, like 55 minutes to write a program, right? And across this 1 hour, he actually used only a max of 3 seconds of processor, 3 seconds of processor time to actually do some processing. That's it, right? Now you can see how costly it can be, right? So your processing, so to keep your processor alive, right? So you have to actually provide so much of power, right, to make it alive. The processor cannot be whenever you want the time of processor, you can't actually switch on the processor and use, right? Your processor should always be on. Now you can see here as I'm moving the pointer here, right? Obviously, which means my processor is whenever I'm drawing something here, which means my processor is actually helping me out to do things as soon as I'm actually doing. Which means I actually see that I'm actually writing on this, right? Because the processor is so fast that it is actually taking my input easily and displaying it as an output so fast that with a naked eye I can't actually feel the gap, right? Sometimes normally if you have opened so many programs and your processor goes slow, then obviously whenever you draw this, right, like anything, then it may take some time to give output. What does it mean? It means that your processor is busy at that time of you gave input, and yes, your input is in queue for the processor, and whenever it gets time to process your request, then it will take up and then it will display on the screen. Which means your processor is busy. The processor request or your input request is delayed for some time, right? So that's what it is. And here you can see this is what we call the single tasking. Now you can see a task here is writing a program, right? Writing a program here is a single task. Now he is loading only one at a time, and whenever he tries to use the processor, it's very minor when compared to the complete timing of writing. So this was a major disadvantage of single tasking which we had. So that's the reason why evolution came up to use processor to do multiple tasks at a time, so that whenever it is doing multiple tasks at a time, so we can actually load things more easily. Right? So let's see how exactly multitasking works. Now when we say multitasking, right? So whatever machines we are using, I think we haven't seen single tasking machines ever, because in our generation, we actually got multitasking machines as soon as we actually entered into market. Right? It was long back that single tasking machines were there. Now, so let's see how the multitasking works. So obviously we need a processor. Let's say it's a processor, right? Which actually takes care of input, instructions execution. And let's say I have got a few tasks. Let's say I've opened my Microsoft Word, right? I've opened my media player, right? And I opened presentation, and let's say I have opened my video studio, right? Which means when I say I opened a Word document, I opened a player, a presentation which is at a time. When I say at a time, with some gap of whatever I opened. Now how it works? Now whenever I open these tasks and keep it open, right? So what happens is, as soon as you click and try to open something, right, your processor will get instruction that user is trying to load a Word, user is trying to load a player and a PPT and a video, which means processor will know that there are 4 different tasks which I have to do. right? Now let's say every processor will have its own, processing, speed time, right? Processing time, right? So let's say this can complete a simple task in 1 second, right? So this processing speed is some MBs or KBs per second, or that much data it can actually process at a time to load a task or accept the instructions and do some tasks, right? So here, so what happens is if you have a Microsoft Word and player, PPT, visual loaded, right? What happens is 1 second will be shared across all the 4 tasks, which means one-fourth of time will be spent on Word document, the one-fourth of time will be spent on player, and one-fourth of time will be spent on your PPT, and your one-fourth of time will be spent on Visual Studio. This is how it actually splits processing time and keeps tasks loading. Now first let's see how it works. Now whenever you open Word, right, so it will spend one-fourth of a second. So let's say if you are opening up a heavy Word document, right, which contains some 1,000 pages and so much of images in it. Now obviously it's going to take some time because one-fourth of a second may not be sufficient to open a Word, let's say, right? And then at that time what it will do, even if it is not taking time, it will spend only one-fourth of a second, that's it. Now as soon as one-fourth of a second is done, it will leave this task and it will move to the next task. And what happens to this Word? Now till the point it actually loaded, right? Let's say the welcome screen is loading, right? And a welcome screen itself took one-fourth second, then it will stay there itself. Then immediately it will move to the next task, right? And this will be queued up. So the processor will actually say the last state of your Word, right? And it will say queue. It will move to the player. Again in the player it will spend one-fourth of a millisecond. Let's say player starts opening up and in one-fourth of a second it was not able to compose completely and it is actually loading some menus and all. Then that's it. It will spend just one-fourth of a millisecond and it will move to the next one. Let's say PPT, the same thing happened. Next it will go to Visual Studio. Let's say Visual Studio have got multiple columns with multiple library loading and third party loading it in the end, right? Then again it's going to take some time. Doesn't matter, it will spend only one-fourth of a millisecond here. Now once it is done, then what happens? Then again, after spending one-fourth of a millisecond, it will actually get back to your. So again it will get back to Word, again it will spend one-fourth of a millisecond. Now from the last state, wherever the Word is opening, right, from that state it will start working. Or let's say from that state it again spend one-fourth of a millisecond and the Word loaded 90%. Then again it will stop there and it will go to player, right? Again let's say your player loaded 97%, again your PPT. Let's say your PPT loaded completely, which means your PPT task is completed. Then what happens? Immediately what it will do, now this one-fourth second is free for all, right? So immediately what it will do, it will actually allocate one-third of seconds for every task. And your player will actually move directly to your Visual Studio. And it will start Visual Studio again. Again it will come back. Now if your Word is loaded, then what happens? Your player and Visual Studio will get half of the second. Then it will come to player. Now let's say your player is loaded, then it will allocate complete 1 second to Visual Studio and Visual Studio. Now this is how actual real-time processor works, right? And now let's say during one-fourth of a millisecond, right, an immediate task got added, one more task got added. Then what happens? So all tasks will again get an equal processing time, which means each task will have 1/5 of a second again, right? That's the reason why if you have good processing speed, if you're using a very good processor, right, then obviously it is going to take multiple tasks where it will actually, as its speed will be high, right, per second, the transformation data process will be high, then obviously it can take multiple tasks. Right? So this is called as multiple tasking, and the way it processes each task, right, is called as a round robin way. Now here is the word round robin game actually. Right? As each and every task will be visited again by a processor to check or to continue the to continue executing the task, right? So it continues in a round robin way to continue each and every task. And every task addition, it will split the time again. And for every task's completion, what it will do, it will actually complete the time of it. So that's how it works. So this is something which is called as a multitasking. Now, why I have taken these examples? Now you can understand that when I say Microsoft Word, this is an application we have. Am I right? This is a desktop-based application which we have where we have to, install your exe and open up. That's it. You are not doing anything else than that. You don't have to write a program or do something to open up your Word. Right? Same way your players, same way your PPT, same way your Visual Studio. These are applications, right? And each application you are using as a task, right? Where accordingly your processor will allocate some memory to run. Obviously, you need a memory, right, to actually run your tasks. Right? Without memory, how can it actually process tasks? No, right? It can. Processor is capable of actually transferring memory, right, where it can actually execute some task. Right? So without memory, it can't do anything. So this memory is nothing but your RAM, right? Which provides some external memory, which is your actual memory used to execute some task. Right? So this is your multitasking we have. Now, if you have multiple processors for a same machine, right, to do tasks, right, then this is called as a multiprocessing. So that is the reason why your multitasking and multiprocessing are not at all same, right? The word may appear to you that okay, they are same, but they are not at all same. Multitasking can be done with single processor. Multitasking can also be done with multiple processors. If you are doing multitasking with multiple processors, then you normally call it as a multiple processor. Now what happens if we have three different processors, right? Now if you have three different processors, let's say, then what happens? Now whenever you load a task, see how multitasking happens. Whenever you load a task, so your task will be allocated to processor. You load one more task, it will be loaded. Load one more task, it will be loaded. So load one more task, then it will be loaded to your first processor. And here what happens is your time will be split. Half and half, one and one. Again loads another task, it will be shared. Now in this way, what happens is your processors will be sharing the actual tasks. Right? So that is the reason we normally say in servers, if you once you start working on real-time companies, right? And if you have to develop or if you have to maintain or if you have to test there, right? Then you will be actually checking out something called super servers, right? Whenever your product goes live, and it's a big client you have where a client may have multiple, huge customers, right? Then obviously you can't have a simple machine to serve a website or anything to them, right? Obviously it's going to be heavy, and the single processing will not work in general. Right, so in that cases, what it will be? Obviously, it will be multi-processing servers, right? Which can have multiple memory slots, right? Which can have multi-cores which can be appended, right? So it will be a super server, definitely, because it is going to take much load, much traffic, right, from the customers. So in that case, obviously you will see. But anyways, you may not see multi-process in regular home premium desktops, right? But it is normally there it will be there in the servers, super servers, right? So this is something which is a multi-processing, and that's how your tasking will be done. So this is your single tasking, multitasking, and multi-processing which we have in here, right? Now, where does threading comes here? We understood, I know, everything as a tasking stuff. And now, if you can see here that I'm running my notepad, right? Now this is a task, right? Where am I doing multi-threading? I'll let you know. So here, as I said, your tasking, right? Whenever you're doing some task, the memory will be allocated, right? So if you can see your manager, which is a task manager, right? Now let's say you are running 5 different programs. Let's say you have Visual Studio, and if you go to process, now you can see here that 99 MB of memory is being allocated to your Visual Studio because it needs that much time. And you can see that each and every process is taking some time. Now you can see whatever programs are running, right? That programs your CPU. When you say CPU, it's like processor is working on that. Right? You can see whatever is running, they are actually working on it. Right? As I'm not using my Visual Studio, let's say it is in idle state where a memory is allocated. Obviously, memory should be there because it has to be alive. So whenever I go back to this, right, then obviously it's going to take. Whenever I start executing and all, it will allocate my processing time. That's how it works. So this is a memory. Now remember, this is a memory which is allocated for a complete task, which is a complete application I'm using. Right? Now, let's go to the granular level here. So let's take a simple task like you have your Microsoft Word. Now let's see what exactly whenever you start doing some action on Microsoft Word, what do we do? What are the different things which you can do? We can write, right? Which is all we can write or type on Word, right? So while typing, what can happen? You have your spell check, right? And you have, let's say, autosave, right? Your grammar check, right? Your indentation check, right? So what are these things? Normally, whenever you are actually writing up, right? So parallel, you will see that your spelling is wrong, your grammar is wrong. You have to check something, right? Your sentence framing is wrong. All this will be running. Now you can see this is my one task, right? Where you are actually doing something, but your background, you can see that while writing, it will give you that your spellings are wrong. It will do some autosave, because whenever your word crashes due to some processor memory out or something, right, or due to some reason, then it will actually save at least few seconds or few minutes back word state, and it will give you that so and so time it crashed and we actually got recovered your data. You want to reset. So for that reason, we have an autosave in your grammar and your indentation checks. Now each in one task, which means for a memory allocated, right? Which means you can see, let's say for some PowerPoint.exe, right? You can see that it allocated 33 MB, right? Which means the complete memory is allocated to, let's say, for a task, let's say 30 MB of memory allocated task. But in that task, using the same memory, right? So many things are running. Now these granular level, things which are running are called threads. And if there are multiple threads running, then it is called as a multi-thread. Now you can see how granular is your multi-thread. You have a task, you have a multitask, you have multi-processing, and when it comes to a simple task, then there will be multiple threads in it, which we normally call it the multi-threading. Now threading is at your tasking level. So that's the reason why you have your processing, your multi-processing, then you have your tasking, then you have your. So they are not all same, they are interdependent. Right? Your multi-threading, your threads, multiple threads will make a task, and your tasks are supported by your process. Right? Now here you can understand that as we are actually creating some application, what does it mean? You are creating a task, obviously, right? Whenever you are creating any library or a desktop application or anything, right? Which means you are creating an application. An application can have multiple threads which can run parallel. Whenever you are typing in, right? Now you can see here, I was typing and it gave me some error. I was typing grammar and it gave me some grammar spell check error, right? I can just check it out, right? So that's how it works. Now, whenever I'm actually moving and typing, let's say, right, enter, it will give some error, which means something is running in my background. So this is your thread which is running. Now, which means we may need thread to do something parallel to whatever are doing. Now let's get back to our program now. Now, whenever we are writing a program, right, what needs to happen? Whenever you run a program, what happens? It will run this statement and then it will go to the next. And if there are any internal methods which we have called, then what it will do? It will actually go to that method, right? Let's say you have print data, right? Now, let's say it will go to this print data and then again it will, which means our program execution is normally a synchronous execution, synchronizing execution, right? It will go step by step. Now there is nothing which is actually running parallel, right? We haven't created anything yet. That's why it is not there, right? Normally, whenever you write any program, let's say it starts with main, right? Whenever you write a program, your .NET compiler will actually create a main thread for you. So every program without a thread, nothing will run, right? You have a main thread already running whenever you start a program. And in this thread, in one thread, every program will run in a synchronized manner. Your synchronized way of execution will be there in one thread. And in this main thread, you can create multiple threads to make it asynchronized. So asynchronized in the sense, your program will actually synchronize. Your program will actually run parallel. That's how you can actually create the multiple threads to run in parallel. We can also do that, right? So this is something which is the thread and what exactly are multi-threads and why do we use them. Now you can see whenever we are running program, if you get multiple threads, even that thread will run parallel. Let's say this method is running in one thread and some other program is running in some other thread. Both the threads will run parallel. It will be very much parallel execution. We'll see that part. We'll see how to create that. Right? So this is about the multi-thread, how it's going to work. Now, getting back to our technical things, multi-threading, all the classes which we are going to use in multi-threading are under system.threading. So this is a mother namespace of all the classes which we have in .NET, right? And the main class here is your thread. So thread is a main class which we have in here. And there are so many other classes like you have thread pool. Now thread pool is nothing but combination of or aggregation of few threads or set of few threads bundled into one tag is a thread pool, right? And then you have something called mutex, and there are a few classes which we are about to see, right? The main classes we'll see which we normally use in our real time, right? So now this is about the actual threading class namespace which we have. Now let's see what exactly is the life cycle of thread. Now normally your thread will have its own life cycle. Let me say. So which is like, let's say you have a thread. So generally whenever you create a thread, it will be in ready state. Right? Ready state in the sense your program is ready to trigger. Right? So your thread, whenever it is in ready, which means you have created an object of thread. So whenever you start your thread, which means your start is a method which you will be using to start a thread. Right? Then it will go from ready to started state or running state. Right? So from running state, you can have two different ways to work with it. One, pausing your thread. Pause. You can actually pause your thread. Right? Let's say we can use sleep method to pause it. Right? Where you're actually pausing, which means for some time you are blocking your thread from running. Now this pause state is reversible, which means you can have a pause which will again get back to your running state. Whenever it is in ready state, it can go to your running state. Fine. Now from running state, other state will be your stop, which means let's say it is abort state or stop. Right? So this is your, killing of your thread here. Now for this you can actually use abort method, direct abort method, or we normally go for some logical closure of thread. Now whenever you go for abort, what happens is in between execution of your thread, it will actually kill the thread abruptly, which may cause some loss of data. So that's why we don't go into that. Right? So this is how we normally do. Now here, in order to do this, now we normally call these as different states of thread. Right? Now this is a ready state, right? And you have your running state or your unstarted state here, right? You go to pause state, right, which is waiting state here, right? And again you have your aborted state, which is your, you have killed your state, which is stop state or suspended state, you normally call it. Right? So these are different states of your thread which we have. And to actually move from one state to other state, we have some methods in thread class, which is start is to start your thread, and something called sleep or resume or spin wait are to actually make your running to pause and pause to pause back to running, right? And your abort and some logical closure directly are to make your thread in non-running state or suspended state or stop state, right? So these all classes and their methods and their states work in that, right? So this is how a normal thread works, and this is same for all. Even our existing thread, whenever we write a normal method, right? It also goes in the same way. Right? So let's see how it is going to work. Let's write a simple program for multi-threading. So let me create a new project for that. So let me close this. Let me create a new project. So here let me call it as threading, and let me make it as a startup project. So here, so this is my trigger point. Now here, what I can do, I can write multiple methods, right, which can trigger, right, multiple times. and then it will be so here what I'm going to do, let me write different methods. So let me make it as click void first. Let's say my method name is first, and I'm gonna write here that console first method something. Let's say first method started. What we are going to do here is we are going to run these two methods parallelly, right? So let me call console.writeLine second and third. Right. So started, and let's say here what I'm going to do, let me just take this type match. So first method and then second, and what I'm going to do here is, let's say I'm going to run this for some time. I'm going to take a simple loop, and let's say I'm going to run for some 20 times. Same for here. You don't have to actually go for places if you have only one single line. That's fine. Right. So here we have two different methods, first method and second method. Right? And I want to run this parallelly. Right? I don't want to call first and second one by one and normally call. Normally what happens is, let's say when I call first and second. Right? So see, you can see here this is static method and these are non-static methods, right? Now can I call non-static method directly into static? Can I call first here? See, if I try to get my method right, it is not being called, right? So which means the non-static methods cannot be called from a static method because non-static methods are called as a object methods. If you remember, static variable or a static method is called as a class variable or a class method. Why? We can access them directly using the class name. How about your non-static methods and non-static variables? You have to create an object of your class to access them, right? To make it quick, normally how do we create an object? Now you can create your object of same class to access your own non-static methods. Normally what do we do? My class name is program here. VJ. Now here I am creating object VJ dot. You can see first. Right? Say we have VJ dot set. Now first let's see this output. Now we haven't created any thread. But what we have done, we are actually doing some synchronous call. Now I'm actually running same things in the same pattern. Let's run this. When you run it, it will immediately open, give output and then close, right? So let's give some time to see the console dot read. Now you can see first method. First it actually completed everything in first method and then it came to second method. To differentiate it, both look same, right? To differentiate them, let's do one thing. So after first method, let's give some different pattern to understand. Right? Where you can see now that your first method and second method are executed synchronously. They are not synchronous. Now let's see how to create a thread. So here your thread is a class which you have to use. Now here, as we haven't used threading namespace, right? That's the reason why it says you have to do threading first. Go here, unnecessary things remove. You can say system dot threading is the one which I want to use. Come back and see you have a thread class. Right, let me call T1. T1 is my thread class. First thread is equal to new. Now this is how we normally create a thread. Now what I have to do, I have to tag this first to a simple thread. How to do that? You have this syntax how we actually create a thread and assign your method to it. Now we have to create an object of thread. Now you can see we have many constructors, overrated constructors for the thread. Now we are going to use the thread start class. Create an object of your thread start. Now you can see your thread start needs a target. What is the target? My obj object dot first. Right? Is my target. Now which means whenever I create this, right? You have to give a direct name, not as a method. Now obj.first is your target. Now we are not calling a method, we are just calling a member of the object. Right? So we are directly calling this method which is in program. That's it. Now this will assign a separate execution path. Also when we say multi-threading, we also call it as a separate execution paths for different separate execution paths for different programs. Right? Now we have created one different path for first. Same way, let's say I'm going to create thread. Let's say T2 is equal to new thread start of, let's say, obj.second. So here I have created my here second. Right? Now here I have created one more execution path called second. Now here I have created an object of first thread and second thread pointing to the actual first and second methods to whom I have to actually make it run parallel. Now this state is called as a ready state. Right? So I haven't executed anything yet, or I haven't triggered anything. So in order to trigger, we will be using the start method. If you remember T1.start. The start method is the one which will actually make your ready state thread to start state. Start. Now this is how it will start your thread. Now which means here we are done with ready state and we are done with running state. Now what is pause state? Pause state is nothing but you are actually stopping your thread for some time and then getting back to running state. These are pause state. Now how to make a thread pause state? Now whenever you create a thread, right, which means physically we can see that okay, T1 is a thread, but normally what exactly is the code which will sit on separate execution path? Now this is your code which will be sitting in a separate execution path, which means this is a thread. This is running on a separate thread, which means if you stop this running, right, if you stop this loop for some time and then continue, then what happens? Then obviously it is nothing but your pause state of your thread and getting back to running state. How to make any thread pause sometime? It is by using your threading dot your sleep method. Thread dot sleep. Now your thread dot sleep is nothing but you're actually making your current thread. Don't worry, whenever you use a direct class thread, it will actually consider the current thread that is running. Dot also you have to give some milliseconds. Actually I am giving some 1000 milliseconds. Which means whenever my thread is running T1, it will run and it will stop for 1 second and then again it will continue. Same way, let's say I am going to make it sleep here. So thread dot sleep of 1000 milliseconds, which means both the threads went to pause state and coming back. When it will be aborted. Now you can see there is a expiry for these two threads. This first method will run only 20 iterations, right? Which means I have a finite iterations defined here. It is not infinite, which means I don't have to actually exclusively kill this, which means there is a logical closure for this, right? This is a certain type of logical closure. It will not run forever, right? So as soon as this method is done and it comes out of this method execution, right? Then your thread will be aborted automatically or suspended automatically. Same way your T2, which means yes, we are safe with killing the thread. Now why I am using a word called safe? If you keep your thread running, right, then it's going to eat up your processor, right? Obviously your continuous thread will actually need some time, right, which will actually make your task running actively, right? Even if you are doing nothing, it will actually make your task running. So that's the reason why it's very important. If it requires to close, we have to close the thread, right? Now let's run this and see how these are going to go. Now we have seen all the ways and all the life cycle ways which we have. Fine. So we have actually covered all the states of thread. Now let's run this and see what will be output. Now when I run this, you can see here, right, that your first method and second are actually running parallel, right? You can see they are actually running parallelly based on the sleep we have provided. We actually gave equal pause time. Now you can see here, first method actually got triggered 2 times. Now you can see the process is something which is going parallel, which means this is nothing but your multi-threading or asynchronous way of execution. Execution in 2 different parts. Fine. Now it all depends on how much sleep you are giving. Let's say I'm actually giving sleep of 500 milliseconds first. Let's see what happens here. See, your first method will be called many times and your second method is taking some time to complete. Right? So once your first method is aborted, now you can see your second method is called. Right? So after 20 iterations, obviously your first method will be aborted. Now you can see second method is running. Now you can see some gap, right? So that execution gap is nothing but your pause state of your thread. You are actually making the thread wait for some time and then continue, right? And then once it is done, it both came out of loop and your threads are aborted, right? Now these two are different threads. As I said, whenever you write any main method or anything, any execution program, even that is separated, which means how many threads I am actually running? I am actually running 3 different threads. One, a main thread, and in that main thread I am running 2 different threads, first and second, which means you can also run a separate loop here. Let's say I am gonna write one more loop here. So let's say I am going to run here some 30 times, and let me make it as console.write line. Let's give some different patterns so that we can understand. Let's do some stars here and say main thread, something, right? And then let's give some thread.sleep. So when I give just thread, right, it will understand what exactly I gave. Let's give some thread. Now it will understand that whenever I give thread, now it will actually take the current thread and it will pause it. You don't have to worry about it, right? Or if you want to be more specific, you can actually go with current thread also, right? Thread.current thread, if you want to go to specific, but there are different methods here which you have to worry about that. You can directly use your thread. Fine. Now you can see how many threads are running. Now one main thread, it will come execution this way. It will start its thread, first thread, it will start second thread, and execution will continue here. Now this will run in separate thread, and this will run in separate thread, which is your execution will be parallel. Now let's see. You can see even there, you can see your main method is going on, your first method is going on, your second method is going on, right, and so on. Right? So this is how your multi-threading, which we know you can see you're actually doing multiple thread, running multiple threads in a single task. Now this is your single task, right? I mean whatever you're doing is a single task, but in this single task I'm actually writing up many threads to run. Right? So this is how we normally create a multi-threading program, right? Where you can actually have things in parallel. Right? Now let's go a step ahead. Now by creating a multi-threading program, right, you may actually get into a situation that you're calling the same method in different threads, right? Which means same method in different threads as such. Let's say you have a single method called doing some calculations, let's say, right? Let me take up a single method in this itself. You don't need a separate class, or if you want, you can also create a separate class as such. Let me call a separate class and do some else and try to replace. Now, even before looking into that, now let's see how to logically close anything. Now let me create one more method here, which is like infinite. Like let's say a public void. Let's say this is infinite calling method. Now how can I create anything infinite? Right? How can I create that? Now I can have a term with semicolon. So if you remember your infinite, normally where do we use infinite threads or a continuous looping threads? Now I'll give you a live example. Let's say you have your mobile, right? Now whenever you get whenever you actually get your signal, or when let's say you are using GPRS and you actually went out of signal, right? Then your GPRS will be disconnected and your applications will not actually have it updated. As soon as you get back to your signal area, right, network area, right, and you get your GPRS enabled and again your signal get back, then you would have noticed that all your applications, right, will actually track that, that your GPRS is enabled and it will start syncing up the server. And if there are any new updates, let's take an example of Gmail app, right, or FP app, then it will actually get all the updates to you and it will actually give you notifications, right? Now, how does it working? How it is working? Somewhere in background, it is continuously checking. It is actually trying to trigger server to check if there are any updates, or your server is pushing data. There are two different ways how you can actually pulse your system, right? Either it can be on demand. On demand is nothing but from your application you are actually trying to trigger, or it's a push. If you see your Outlook app, right, now then you will have an option like how do you want to get updates? Is it from push or on demand or some other option? Your push from server is nothing but the server will actually get, whenever you have an app connected, right, you will get a continuous pulse, right, to update your status. Now in that continuous update, how it is going, obviously something is going, some background work is going continuously to check, right? So that can be one example that you may have to work on, right? So here let me say this as console.writeLine. I'm just going to call something which is an infinite text, right? Just to show that this is something which is infinitely fun. And let me call some thread dot sleep. Not much. I'll take 200 milliseconds. Okay. This is my infinite call, right? So here let me call thread t3 is equal to new thread t3 or thread start of your object dot, let's say, infinite. And let's start a T3. Right, so this is going to be the infinite call method which is going to trigger. So let's run this and see how it works. Now you can see, whatever you can see in bold and right, which means that is the one which is running infinitely. But you can see parallelly your first method, second method, and your main thread are running. Right? As you have small pause for your infinite, right? That's the reason why you can see more iterations being triggered for the infinite, and your less iterations for your main thread first thread. I'm just taking an example to show you that. Right? Now you can see only your infinite thread will be running. Now this will never stop because we haven't considered any abort of this thread, or we haven't done anything, which means unless I kill this program, this thread will be running forever. Right? Now as I have code, right, I have code here normally. Now which means what does it mean? It will run infinite, and let's say if this is a background and it doesn't have any user interface, then this thread will be running forever. Now as I'm running from code, I can stop from here, right? Or else what I can do, I can go to the I can actually go to the process. Let's say this is my process running, right? Go to process. Now this is my actual process being running, which is my actual process. So maybe close this. Let me close this. Now your thread is stopped. Normally you don't get code to actually kill your program, and in that case, if you go ahead and close that, right, whatever memory it is consuming will be freed out for some other process. Sorry, some other task. Right. So that's how it is going. Now, how can we kill this logically? Is, let's say, see, we just have seen few statements that normally infinite loop. What will be doing? Let's say you are continuously checking your socket whether you got a connection or not. Right? Whether you actually are trying to read a socket and do some connection and then do some task. Right? There will be so many things which will be done. So to actually make it closure, now you may have to check something like, let's say something like I'm going to take here itself. What I do, I just do something like right in this class program. Let's say I have a simple thing is done. I'm just taking an example. So once my main method, everything is done, let's say after some time, let dot sleep of, let's say 200 milliseconds, I want to stop my infinite thread. So what I'll do, I'll say is done, or let me say visual dot is done is true. What does it mean? So my thread is actually waiting for some time, and then whenever it says is done, yes, it will be done. And then I will be using this in my instance. Now here, what I'll do, whenever there is if is done, I'll break. Now whenever I break this loop, what does it mean? I'm actually breaking this complete thread. I'm actually breaking. So this is something how you can actually logically close your thread itself. Fine. So let me run this. Thread is running now. Now you can see after your main thread is done, right, for 2 seconds it will run, right, and then it will stop, which means now you have your logical closure. Fine. So this is how it's right. You can actually have your infinite loops being closed first. So this is about threading and how we actually create multiple threads and call them parallelly, and what is the main thread, right? How it actually works. So this is for today, which we